7 QC tools are quality control tools that are used to identify manufactured products or services that does not meet quality standards, identify their root cause and work-related issue in an effective, efficient and result-oriented manner. It includes analysis and resolution. Quality control is a philosophy that originated in Japan and is one of the most focused area in any industry today and the area where you get the most work. But, what is quality? Quality can be defined as fitness for purpose. To do the right thing at right time. To do the right thing the first time and every time. Conformance to standard. Standard of object compared to others of similar properties. Hello and welcome to this course. In this course we will be learning what is quality control, history of quality control, founder of Quality Circle Kaouru Ishikawa, list of quality tools, cause and effect diagram, check sheet, control chart, histogram, Pareto chart, scattered diagram, and flow chart. If you like this type of content, then like this video. Subscribe to the channel and press the bell icon so that you don't miss out on any update. Also feel free to comment in the comment section and leave a feedback. As we know, the biggest asset of any company is its customers. Many companies cannot exist if it does not have any customer, and the only demand that keeps the customer intact with any company is quality. In order to maintain this quality, every company that cares for its customers have quality control department. Duty of this quality control department is that it maintains the quality of the product. Each quality control department uses some tools to make their work easier. These are called quality control tools. Now, what is quality control? Quality control is a philosophy that originated in Japan. Quality control uses quality control tools to identify manufactured products or services that does not meet quality standards, identify their root causes, and work-related issues in an effective, efficient, and results-oriented manner. It includes analysis and resolution. Quality control philosophy have some tools called as quality control tools. There are 7 quality control tools. Quality experts have given many names to these 7 important quality tools, first highlighted by Kaouru Ishikawa, the father of the quality control circle. 7 QC tools can be applied to various industries from product development stage to delivery. The 7 QC tools are still as popular today and are widely used at various stages of Six Sigma, DMAIC or DMADV, continuous improvement processes, PDCA cycle, and lean management, removing waste from the process. History of 7 QC tools. The 7 basic quality tools, also known as the 7 QC tools, were born in Japan when Japan was undergoing a major quality revolution and became a mandatory subject of Japan's industrial training programs. These tools consisted of simple graphical and statistical techniques that help solve serious quality problems. These tools are called the 7 basic tools of quality. The 7 QC tools are believed to have been introduced to post-war Japan by Kaouru Ishikawa, inspired by Benkei's 7 famous weapons. Benkei, a Japanese warrior monk armed with 7 weapons, was on a personal quest to capture 1,000 swords from samurais he considered arrogant and worthless. Dr. Ishikawa was influenced by a series of lectures on statistical quality control delivered by W. Edwards Deming to a group of Japanese scientists and engineers in 1950. Unfortunately, the complexity of the subject threatened most workers, so Ishikawa focused primarily on reducing the toolset sufficient for most quality-related issues. Kaouru Ishikawa, also known as the father of Quality Control Circle. He was known for his role in Japan quality movement in 1960s. He was part of the Japanese Industrial Revolution for improvement in quality and quality control. He developed several tools for quality control like Ishikawa diagram, also known as fishbone diagram or cause and effect diagram. List of quality tools. Following are the quality control tools, cause and effect diagram, check sheet, control chart, histogram, Pareto chart, scattered diagram and flow chart. Once a quality-related problem is defined, the factors leading to the causal of the problem are identified. We further keep identifying the sub-factors leading to the causal of identified factors till we are able to identify the root cause of the problem. As a result, we get a diagram with branches and sub-branches of causal factors resembling to a fishbone diagram. Cause and effect diagram. Cause and effect diagram, also referred to as fishbone diagram, are a quality control brainstorming tool used to help identify the root cause or causes of an issue by looking at all possible variables. This tool was designed by Dr. Kaouru Ishikawa, hence this tool is also called as Ishikawa diagram. It was developed in 1943. Cause and effect diagram helps in identifying the various causes, or factors, leading to an effect, or problem, and also helps in deriving meaningful relationship between them. How to make a cause and effect diagram. Following are the steps that are used to make cause and effect diagram. State the undesirable effect or problem. To start with the cause and effect diagram, make all the lines that looks like a backbone of a fish. On the right side of the fishbone write the major effect for which the cause and effect diagram is being made. Identify the main cause group. Next we go for the cause. To identify the cause we use 6M method, that is, man, methods, machines, material, measurements and Mother Nature. Arrange the cause and sub-causes as relevant. Now after noting each of the categories we think of subcategories that can go inside each of the relevant cause. Identify potential root cause. Now we start with the why analysis. Since we know the category of each cause, we now ask ourselves why and provide the answer, then we ask next why from that answer till we find the root cause of the problem. That root cause is noted. Check sheets. Check sheets are one of the important quality tool out of 7 quality tools for quality control that are likely to be used in any industry or service process. The check sheet is a document that was founded by Kaouru Ishikawa. A control sheet is a simple document that helps you collect, present, research, and search data. It is used to collect data to understand qualitative and quantitative variables that can affect the process. The check sheet can be defined as follows: a systematic way to collect, record, and present relevant data in a simple way for process analysis. The ultimate purpose of the checklist is to list important checkpoints or events in table, metric format and constantly update or flag the status of occurrence. This helps to understand progress, failure patterns, and even the root cause of failure. There are several types of check sheets depending upon their use and purpose. Some of them are as follows. Process performance. This type of check sheet is used to track the performance of a process. This may include a number of defects, failures, and so on. Error occurrence. This check sheet contains all the errors that can occur at a particular process station and checks for any errors that occurred during the process. Defects that occur are marked on the sheet. Error location. The error location check sheet is used to identify the location of the error. This inspection sheet consists of images of processes or parts, and the operator must mark any defects on the sheet with them. Task confirmation. This check sheet is used to confirm that all processes have been completed. Small screws, nuts, fixing parts, etc. Make sure the assembly is in place and you haven't missed anything. Cause of the error. This check sheet is basically a root cause check sheet and helps you define the cause of the error and mark the sheet. This helps to quantify the most common causes of error. Now, how to make a check sheet. Following are the steps that are used for making a check sheet. Determine the required information first. You or your administrator must determine whether the purpose of this check sheet is a process performance check sheet, a defect item check sheet, or a defect location check sheet. Determine 5W and 2H. After deciding the purpose of the check sheet, decide 5W and 2H, which are as follows. Why you need data. What information required for data output. Where to collect data? Who needs to collect the data? When will the data be collected? How to collect data? How much data is required? Construction of check sheets usually have a title in the top bar. Below the title is basic data such as the name of the project, the location or area of data collection, date, time, and person records. Below are the row and column data, including the data to measure and the amount. The final stage is the testing stage. In this stage, the sheet is shared with multiple users based on their importance and you are prompted to collect data. After collecting the data, analyze whether the data is complete or it has something missing or if there was a problem during the data collection. Remake the sheet and repeat this process until you are satisfied with the results. Once all the stages are completed, show this to management before implementation for approval. Next, training for relevant data collectors, data organizers, and data separators must be conducted. Control charts. Control charts are very popular and commonly used in quality control techniques, Six Sigma, and also plays an important role in defining process capacity and production fluctuations. Control charts are graphs used to show the performance of a process over time. This is basically a statistical chart that helps you determine if an industrial process is controlled and can meet customer-defined specification limits. Subgroups of data points are collected and merged in a short period of time. The average of the data points in the subgroup is represented as a single point on the control chart. The amount of variation present in the sample dataset is the standard deviation and is used to determine the control limits. A process is said to be unmanageable if the subgroup is outside the control limits or shows certain patterns or trends. The control chart is also known as the Shewhart control chart, named after Walter A. Shewhart. The real purpose of the control chart is to determine if the process is running stably under the current conditions. The purpose of control chart. Control charts provide an overview of the history of process data to help distinguish between special cause deviations and common cause deviations. Common cause. Unknown malfunction. They change the process with a random distribution, but never significantly above or below control limits. Special cause. The special all cause is a known malfunction. They cause major failures and defects in the long run. Data typically goes above and below control limits. How to make a control chart. Following are the steps for making a control chart. Determine the type of control chart. Decide and determine which type of control chart is to be made, like whether production data, defects data, process variation, etc. Also decide the period of time for which the control chart is to be made. Collect the data. After deciding which type of control chart is to be made, start collecting the actual data over a period of time. Determine the subgroups. Subgroups can be calculated using the formula, which is as follows, where n equals subgroup size required. Zeta alpha 2 equals the number of standard deviations above 0 on the standard normal distribution such that the area in the tail of the distribution is alpha 2. Alpha is the type 1 error probability and is typically 0.0027 for control chart applications. In this case, zeta 0.00135 equals 3. Zeta beta equals the number of standard deviations above 0 on the standard normal distribution such that the area in the tail of the distribution is beta. Beta is the type 2 error probability. Sigma equals the standard deviation of the characteristic being charted. D equals the difference we are trying to detect. Determine overall average. After collecting the data for a certain amount of period, calculate its average. This will be the centerline for data. Calculate the range. To calculate the range, we must use the following formula. Compute the average of the range. Average range can be calculated using the formula. Calculate the control limit. Using the data of X bar and R bar, calculate the control limit for the specific graph. Plot the data in graph. After all limits are calculated, draw the graph and then plot the data on the graph. Interpret the graph. Interpret the data to check the behavior of the data to find the behavior is within limit or outside limit. Histogram. Histograms are a type of bar chart that visualizes the distribution of numerical data. Its structure is similar to that of a bar graph. Each bar in the histogram represents a group of data, and the height of the bar represents the frequency of the data in the group. This is a powerful quality planning and management tool to help you understand precautions and corrective actions. Histograms help clarify the frequency distribution of data from groups of samples and help identify areas of improvement in the process quickly and easily. It is a pictorial representation of data. It is the most commonly used bar graph for recording frequency distributions of data. This tool helps categorize the frequency of your data into age, days of the week, or any other data that can be represented chronologically or numerically. The histogram is an excellent quality planning and control tool which supports us to comprehend protective and appropriate actions. How to make a histogram. Following are the steps to make a histogram. Use of histogram. First, determine the process, product, or purpose for which you want to use the histogram. Data collection. Then start with data collection. Get 100 to 150 points of data to create a histogram of appropriate length and analyze the data better. Area calculation. Calculate the area by subtracting the maximum value from the minimum value of the data. Specify the number of intervals. Specify the number of intervals to divide the range. Determine interval width. Determine the width of each interval for easy plotting on the graph. Dataset summary. Summarizes data at intervals and counts the frequency of the data over a range. Create graph. Create a graph using the data. Chart pattern analysis. Analyze trends and extract the required data. Pareto chart. The Pareto chart is a combination of a line chart and a bar chart. You can use the Pareto chart to find the facts you need to prioritize the defect or problem to be focused on resolution. Pareto charts organize and display data to clarify the overall meaning of the various problems and the reasons for the problems. The Pareto chart contains a bar chart. The errors are displayed in order, highest to lowest, and the line chart shows the cumulative percentage of the results. Helps identify the facts needed to prioritize the problem to be focused on resolution. Pareto charts organize and display information in a way that makes it easier to understand the relative importance of various problems or their causes. How to make a Pareto chart. Following are the steps for making a Pareto chart. First, you need to choose the problem you are investigating and how and when you want to collect the information. Then, if necessary, create a check sheet to collect the information. Collect, experience and organize data to calculate cumulative percentages. Next, you need to draw charts, bars, cumulative percentage lines and add labels. Examine the chart to identify some of the trivial many problems with the 80 by 20 principle. Plan further steps to eliminate the detected error by identifying the cause. Scatter plot. Scatter plots are also known as scatter diagram, scatter graph, scatter charts, and scatter grams. Scatter plots are one of the 7 most popular QC tools to help you see how the two variables are related. This chart shows the values of two variables plotted along the two axes of the chart. The pattern of points in the result reveals the correlation. Scatter plots can be used when one continuous variable is under the control of the experimenter and the other depends on it, or when both continuous variables are independent. If there is one parameter that is systematically incremented or decremented, it is called a control parameter or independent variable and is usually plotted along the horizontal axis. The measured or dependent variables are usually plotted along the vertical axis. In the absence of dependent variables, any type of variable can be plotted on any axis, and the scatter plot only shows the degree of correlation, not causality, between the two variables. Scatter plots can suggest different types of correlations between variables with specific confidence intervals. For example, weight and height are displayed on the y-axis and height is displayed on the x-axis. Correlation can be positive, increase, negative, decrease, or zero, uncorrelated. If the dot pattern slopes from the lower left to the upper right, this indicates a positive correlation between the variables under investigation. If the dot pattern slopes from top left to bottom right, it indicates a negative correlation. You can draw the best line that intersect most of the points, or called the trend line, to find out the relationships between the variables. The equation of correlation between variables can be determined by an established optimal method. For linear correlation, the optimal procedure is called linear regression, which guarantees the correct solution in a finite amount of time. The universal optimal procedure does not guarantee the correct solution for every relationship. How to make a scatter plot. Following are the steps to make a scatter plot. First, you need to collect the data needed for validation. Recognize the causal relationship between two variables. Find the dependent and independent variables. Dependent variables plotted on the vertical axis are called measurement parameters, and independent variables plotted along the horizontal axis are called control parameters. Next, draw the chart according to the collected data. Add the names of the vertical and horizontal axes and plot the trend lines. Examine the graph using trend lines to understand the correlation. Correlation can be characterized as irrelevant, strong, and moderate. Flowcharts are probably the most popular of the 7 quality tools used for quality control. This type of quality control tool is useful for analyzing large amounts of data. Flowcharts are a visual representation of a process that can explain the following: which activities are performed by whom and in what order. Handoffs between departments or individuals. Internal and external operational restrictions. This tool is used for data collected from various sources such as people, shifts, machines and suppliers. In addition to showing the entire process, the flowchart also emphasizes the relationship between steps and process boundaries, start and end. You can use this tool to visualize a series of steps such as processes, systems, workflows, events, and more. In addition to the complete representation of the process, the flowchart also shows the association between the phases and the process boundary. Flow chart use a standard set of symbols, and it's important to standardize the use of these symbols so anyone can understand and use them easily. Here's a roundup of all the key flow chart symbols. It first groups all the homogeneous or similar data into smaller groups of data called strata. To get the best results from stratification, make sure to include which information about your data sources may affect your analysis results. Oval. The oval icon marks the start and end of each process. The flow chart diagram states that the start is written inside the symbol and similarly end inside the symbol at the end of the process. Flow or arrow line. The flow or arrow line shows the progress of the operation. The head of the arrow represents the next process, and the tail, without the arrow, represents the previous process. Diamond. The diamond symbol is used when a decision needs to be made. This decision can be yes, no or true, false. Rectangle. Rectangle icon is used to change the value, shape, or position of the data. Parallelogram. This symbol is used for input and output data. Single document chart. Used to display a single document on any chart. Duplicate document chart. Used to display multiple documents on one chart. Delayed activity. This icon represents waiting. Where there is no activity. Triangle icon. This icon is used for inventory. This inventory may be in progress or terminated. How to create a flowchart. To create a flowchart, follow the following steps. First, you need to form a team of staff who are familiar with running the analysis process. Next, you need to make a list of all the phases involved in the process from start to finish. If you use digital tools such as Microsoft Office, you can write down the steps of the process first and then draw them on the canvas when you identify the flow later. Recognize the order of steps. Whenever you draw a flow in a flowchart, look at it from top to bottom or left to right. Link shapes with arrows to show flow. So this marks the end of our course. If you like this course, then subscribe to the channel and press the bell icon so you don't miss out on any update. For more courses and blogs, click the link to our website in the description. Also follow us on Facebook, Instagram, Twitter and LinkedIn. Thank you.